So, welcome. Now, concerning about the previous class, the previous tutorial video. So, what actually, whatever I've explained so far is actually based on the summary on statistics for management and social sciences, whereby I gave you the two main branches of statistics and then explained that okay, data can be represented graphically, diagrammatically, and even though you can measure those data. And I gave you how to measure it. I gave you all the contents under measures of data, whereby we have the measure of central tendency. So here in this video, I'm starting with the first one. The first one we have under it is the measure of central tendency. So class, this is the first one. This is the first one. Now, remember that I said for measure of central tendency, which I denoted as, I abbreviated this as MOCT, okay? The first thing we have under this thing, if you remember, was just mean, then the median and the mode. So for this mean now, mean is denoted as X bar in this case. X bar, take note of that. And at the same time, this mean is also called average. Please take note of this. We call it average sometimes. And then it has its own formula. So is that you call it average or you call it arithmetic mean, and that you want it. All I just know is that, okay, if I want to express this in word, then I say, okay, arithmetic mean. That's the first thing we have under it. What is arithmetic mean? Arithmetic mean is trying to tell you that if you take the sum of all the data given to you, I don't have just one data. X is the data given to me, but I have several of them, which is what I have x1, I have x2. So let me just label it xi, whereby I ranges from 1 to wherever I want to stop. So just take the summation of all the data given to you. This I is telling you you have just several data that is being given to you, okay? When I is 1, I have x1. Summation means plus. Then what's the next value after I equals to 1? That's I equals to 2. Then x1 plus x2 plus x3, then like that. Then after adding everything, then arithmetic mean says that just try to find the average by dividing it by the number of items you have in that data, which is n, which is small letter n. So for example, if we have 2, 4, 6, if this is a data and I want to find the arithmetic mean, so I think this is, we are all familiar with this, then arithmetic mean will be equals to x1. This is x1, this is what I'm saying, this is x1 now, this is x2, and this is x3. Do you understand that? Whereby I is 1, when I is 1, that means I have x1 and x1 is 2. This sign you have here is called summation, or you call it sum all. So sum the next one, sum the next value, which is 4, which is x2, and next one is 6. So divided by the number of items is how many? 1, 2, 3. So by the time we add this together, 2 plus 4, that is 6. Then 6 plus 6, that is 12. Then you have 12 over 3. This gives us 4. Hence, the arithmetic mean is 4. This is very, very simple to solve. And at the same time, after this arithmetic mean, we have the geometric mean. Remember that is what we have under measure of central tendency. As you can see, I still have it here. Now I can decide to mark this now that I have an idea on it. Next thing now to do is to find the geometric mean. Class, what is the formula for geometric mean? Geometric mean is just trying to tell you that consider the number of items you have here. How many number of items do you have here? That's 3. Just take the cube root of the product of each of the items given to you in your data. So to represent or to give a general formula for that, then that would be number of items is n, right? So you are taking the nth root of the product of each of the data given to you. That is, I have x1, then times the next data is what? X2 times x3. So it's not a must you have just 3 data. So you can have it, you can keep on multiplying them until you get to what? The last value xn. So the formula for geometric mean is just nth root of x1 times x2 times x3 times dot 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 dot, then up to when you get to the last term, which is xn. Do you understand that? Now let's find the geometric mean of this same data. Okay, given 2, 4, 6. Class, what is the geometric mean? Hence, geometric mean simply implies Count the number of items you have. How many are they? 1, 2, 3. That's cube roots of multiply them together. 2 times 4 times 6. And then it is advisable you use your calculator from here instead of you stressing yourself before you get the correct answer. So to get the correct answer to this, I think I have my calculator here. So you can make use of a natural display calculator. Then to press this, I want to press cube root. Then just press shift and this square root sign. And then I have my cube root. But suppose you have 4 datas, then that will be 4 truth of. And then you have to just remove this 3 by pressing this left button. And then remove the 3 and put whatever choice you want, whether 4 or 5. So I'll still leave it as 3. And then I put 2 times 4 times 6 inside the square root. So whatever I have now is 3.63. So 2 decimal places. Hence, geometric mean is what? The result we have for geometric mean now is 3.63. So take note of this. Class, what's the next thing to do? Harmonic mean. What is harmonic mean? Harmonic mean simply implies that you are trying to count the number of items given to you. This is it. Is the ratio of the number of items to the reciprocal of each item. The ratio, like saying the ratio, that's the ratio of the number of items, which is n. Number of items is n. So the ratio of these two to the reciprocal of each item given to you, okay, that is n divides, when I say ratio, n divides then the reciprocal of each of the item, that is 1 over x1, the ratio of the number of items to the inverse, to the summation inverse. How will I even put it? Just sum all this number of items, then you take the ratio with the reciprocal of each item in such a way that you keep on adding it together. Okay, you add them up to get to 1 over xn. So that's how it works. Okay, just take n over 1 over x1 plus 1 over x2 plus 1 over s3, then like that. So it's just like trying to tell you that you have I can write this mathematically. Mathematically speaking, this represents I have n, right? So you should have something like this: n summation I start from 1 to n, then you have 1 over xi. So this is the main formula for what? Harmonic mean. That is, this is n itself. Okay, so just take the summation of 1 over, this is 1 over, then you take 1 over xi, 1 over xi. This is how it is. So next thing for us to do from here is to try an example. I'm still using the same 246. How many number of items do you have? I have 3 of them over, then 1 over, what's x1? X1 is 2. What's x2? X2 is 4, right? And x3 is what? 6. Then that's all. That's the last time I have in my own work. So I can get the final answer to this without even stressing myself. This is 3, then press this box over box button, then 1 over 2 plus 1 over 4, then finally with plus 1 over 6. So whatever I have left now is 3.27, as you can see trivially. So the harmonic mean is 3.27. So that's how it works. And then finally we have what we call the quadratic mean. How do you find the quadratic mean? That's QM. QM is also known as what? Root mean square. According to what I've actually explained before, quadratic mean is also known as what? Root mean square. And then the main definition is actually coming from this statement that we have just said now. The root, can you see that? The root, the mean, how do you find mean? X1 plus x2 plus x3 plus up to xn, right? X1 plus x2 like that. Then over number of items, right? Over number of items. Now, what is the square saying? Square your result, but not, you can't square n. If I put square here, then that means I've actually changed the question, because the number of items given to me is just 3. For me to put a square here, then I'm telling you, I'm trying to give you a notification that, okay, that means the data given to me initially is that's 3 square. Is it 9? No. So I can't put square on this. I can only put square on each of the datas. Okay, square. So this is the formula for root mean square, which is quadratic. Quadratic mean is x1 square plus x2 square, and like that. So final answer will be, using the same example that we have here, we are going to have square root of, what's x1? That's 2. Just square the result. 2 square plus 4 square then plus 6 square over what? over 3, three of them. So I can just use my calculator to do that. Square root, put a fraction, put in 2 squared, then plus 4 squared, then plus 6 squared, and then finally divided by 3. So quadratic mean we end up giving us what? 4.32. Hence, quadratic mean is what? 4.32. Now, class, you have to take note of their relationship. This is very, very important. I noticed that when I compute the value for AM, arithmetic mean, I got 4, right? And then the next thing, when I tried geometric mean, I got 3.63. And then for harmonic mean, I noticed that after solving for harmonic mean, I got 3.27. And then the last one is quadratic mean, 4.32. So I noticed something. There's a, for your own level of, in your past question, I think this is part of your question, the relationship that exists between AM, GM, and HM. That's what it is being stated. But in this video, I'll try to relate everything together. So QM, I got 4.32. What I actually noticed from here is that this thing is decreasing. AM is 4, GM is reduced, and HM reduced. So I noticed that AM is always greater than GM and HM, and GM is always greater than what harmonic mean. So, but the greatest of all is the quadratic mean. Quadratic mean now is always greater than all of them, 4.32. So now, how can you show the relationship that exists between arithmetic mean, geometric mean, and harmonic mean? I noticed that let's relate this three first, then I'll relate everything. So I'm using this three at first. I noticed that GM is in the middle. This is GM, right? So to represent this, if I want to use less than, so GM is less than what? That's my first question. GM is less than what? AM. Forget about the quadratic mean for now. So GM is less than AM. Do you agree with that? And at the same time, what else is, when you're trying to find the range, if this is less than, you must have a less than here. Not that you have less than and greater than, it's not allowed. Okay. Now you have GM to be less than AM. So what else is less than GM? Trivially, it is what? It is HM. But do you know that this particular um relationship is not sufficient enough, or it is not um valid enough, because I can also have it to be equal to each other. It can only be equal to each other if you just have a unit value. That's a unitary data. If I just give you a data, just one. If I ask you to find the arithmetic mean, that's how is still one. Arithmetic mean is 1/1. What's geometric mean? Geometric mean is 1/1, which is still one. If I ask you to find the harmonic mean is 1/1/1 is still one. So everything can also be equal when it's what? Unitary. When you have a unitary data that is just one, it's single data. So that is not that when you have five. When you have five, it will be different entirely from each other. So now, if I have a unitary data, they can also be equal. So the best answer to this is HM is always less than or equal to GM, and at the same time, it's also less than or equal to what? AM. Please take note of this. Otherwise, I can decide to, if you not see this in the option, you can also see this in the option. I use less than. What if I use greater than? You stand that. If I use greater than. So GM is greater than what? Normally it's greater than HM. You stand that. And what if I use greater than here? I told you that you must not have an interchange sign here. So it must also be greater than. So what else is greater than GM? And that is what? That is AM. So is it that you see one of this in the option? But take note, the best answer is to have it greater than or equal to. Okay. Now, since we have this now, um, that means these are the two results we could have for the relationship. So trivially, if you notice that if I try to swap this like a mirror, just turn it sideways. When you turn this sideways, you have this back. This sign changes to greater than, as you can see. So it does not affect. And then this gives the result. But what is the relationship that exists in everything? So if I'm starting with GM, whatever I notice that GM is less than HM, right? Sorry. GM is less than AM rather. And AM is less than what? Is less than QM, quadratic mean. So what else is less than GM? And that is what? HM. So this is the relationship that exists in everything. Okay. And at the same time, sometimes it can also be, this is one relationship. Suppose I still have that past question. There is one in this case that says that HM, I think the question came in this format, GM plus 2, and which of the following is correct? So I saw something like this. So whatever you have to do is to just pick a sample yourself, and then you just try to check whether it is satisfied. Any of it that is satisfied. Because looking at this now, if I have an option that looks like this, okay, and I'm trying to confirm, okay, let's check. GM, the GM we have is just 3.62. By the time you add 2 to it, by the time you add 2 to this one, you have 5.63. And 5.63 is not less than the arithmetic mean. For the same data, coming from the same data, it is not. So that means this expression is wrong. So just look for the best one that is correct. But this is the main relationship, 1, 2, 3. So please take note of it. So this video I've actually explained everything you have to know on mean itself. That is mean, geometric mean, done. Harmonic mean, now you have an idea. Quadratic mean, I've explained. So in our next video, I will explain what median is and what mode is. So you see, we still have a lot of things to do. Okay, so let's just take it in a gradual process. Let's just take it gradually. So class, that's how it works. Thank you very much. Thanks for watching. I really appreciate it.